this is the page 1 of the homework in the pre-AP solutions unit. So I just wanted to go through some of these questions. They would mostly pertain to the first day video that for video notes. Okay. Describe the hydrogen bonding between water or between molecules in water. Well, remember how water is drawn. There's a couple of hydrogens bonded to an oxygen. Ooh, that's better. And then that oxygen has lone pair electrons on it. So there's a force of attraction, a very strong force of attraction between molecules that have a hydrogen bonded to, remember, either a fluorine, oxygen, or nitrogen. Well, water obviously has a hydrogen bonded to the oxygen. So that makes this thing really superpolar, makes this a real positive end and this a real negative end. Well, what happens is this little thing will rearrange itself and there will be a force of attraction between the negative oxygen end and the positive hydrogen end of a nearby water molecule. Okay, so this strong force of attraction right here is a hydrogen bond. It connects the two water molecules together and holds them together pretty tightly. So let's go on some different things in the homework packet. I just want to do a few of these with you. What's the significance of the statement like dissolves like? Well, that means polar solutes will dissolve in polar solvents. Okay, this would be like KCl will dissolve in water because they're both polar. Okay, so like things dissolve in other like things. What does like refer to? Like means polarity. Similar polarity. And by similar polarity, I actually mean nonpolars will dissolve in nonpolars and polars will dissolve in polars. An electrolyte versus a non-electrolyte. An electrolyte will conduct electricity. Okay, electrolytes conduct electricity. In solution. So that potassium chloride up here, that will conduct electricity in solution because this KCl will break apart into K plus and Cl minus when it's dissolved in water, when it's dissolved in some sort of beaker of water. Okay, it'll break up into its little charged particles, and so it'll be able to conduct electricity while it's in that solution. Something would be a non-electrolyte. A non-electrolyte would be like, let's say something that's super non-polar covalent. I'm thinking. I hate to give you something simple like a gas, because you can dissolve a gas in a liquid. So let's say we're going to dissolve some nitrogen gas in water. Well, it's really not going to work because remember how nitrogen is? Nitrogen's super duper nonpolar. Nitrogen has that triple bond and it looks like that. So this is a really nonpolar compound. So this thing, you could dissolve, if it dissolved in water, it would definitely be a non-electrolyte. Now, a covalent compound that would be polar covalent would also form a non-electrolyte. So let's say ammonia. Ammonia is NH3. And it would be drawn, let's see, nitrogen, and then you'd have those three bonded hydrogens. So this thing is polar covalent. So it will dissolve in water, but it won't form an electrolyte because it's covalent, because it won't break up into these little ions right here. Okay, it stays together when it's dissolved. Okay, solvent and solute in vinegar, which is a dilute aqueous solution of acetic acid. So I want the solvent and the solute in vinegar. If it's aqueous, that means it's dissolved in water. So water is the solvent. And so that makes acetic acid, C2H3O2 is the solute. So acetic acid would be the solute, and water would be the solvent because it's a dilute aqueous solution. So that means it's dissolved in water. Let's see. Let's look at number 10. What is the effect of pressure on the solubility of gases in liquids? Okay, well, think about your soda. When you have the lid on your soda, you keep the pressure on. You can feel the pressure. And what that does is it keeps the gases dissolved, keeps the CO2 dissolved in your soda. It makes it real bubbly. But when you undo the lid, then all those gases start to come out. The pressure's not there anymore. We take the pressure off, and all those little gases will come out of solution. So what effect does pressure have on the solubility of gases in liquid? Increased pressure means increased solubility of a gas in a liquid. Okay, so that's all I'm going to do on page 1. So let's look at page 2. Sorry, just kidding, page 2. I'm not going to do a bunch of these, but oh, how I love to do them. They're so much fun. All right, let's do number 2. Number 2 is real simple. We use this all the time. What's the name of this stuff? It's in your gas jets. Okay, well, street name, methane. O-M-E-T-H-A-N-E. Formal scientific name, carbon tetrahydride. Okay, Lewis structure. To draw this Lewis structure, remember that carbon's special. If there's carbon in the compound, it's always in the center. You do one single bond for each of the remaining atoms. There's 4 hydrogens, so I'm going to connect each of the 4 hydrogens. Okay, then I'm going to check for an octet. Carbon has 2, 4, 6, 8 electrons circling it. Each hydrogen, remember, only needs 2 electrons to be happy. So each of these hydrogens is sharing 2. So the hydrogens are happy. So this is my Lewis structure. So is it ionic, polar covalent, or nonpolar covalent? Yep, it's nonpolar covalent. The way I know that is there's not different things bonded to that carbon, and there's not a lone pair anywhere on that carbon. Okay, will it be soluble, insoluble? Oh, here, let me move that over. Will it be soluble, insoluble in water? What do you think? Well, nonpolar covalents are insoluble. There you go. Sorry. Oop, there's another one. Okay, I'm going to do some that are not boring. I'm going to do this one. This one doesn't look boring. So I'm going to do number 8. I'm going to draw this structure. I really should sharpen my pencil, but you're just going to have to be okay with it right now. Hydrogen has how many valence electrons? Yeah, it has 1 valence electron, and there's 2 hydrogens. So there's 2 valence electrons for hydrogen. Plus, how many does sulfur have? Find it on your periodic table. I need to upload a periodic table for you if you can't find yours. Okay, sulfur's got 6. And each oxygen also has 6 valence electrons, but there's 4 oxygens. So 6 times 4 is 24. So when I add these up, let's see, that's 6, and this is 20, 32. So that's 32 electrons in my structure. What's its name? Well, in my wildest dreams, you would remember how to name acids, but it's not binary, so it doesn't get a hydro. So the name is determined by the polyatomic ion attached to it. SO4 is sulfate. If I ate something icky, that means sulfate turns into sulfuric acid. So this is sulfuric acid. Not painful, right? Okay, so let's see. The Lewis structure. So which one do you think is going to be in the middle? I'm going to go with sulfur in the middle. This is going to be a tricky little structure. So I've got 4 oxygens and 2 hydrogens. Let's see. So I need 4 oxygens. And remember, hydrogens are going to have to be on the end. So let's see what we can do here. Oxygen. And then I'm going to bond me some hydrogen somewhere. I'm going to hit them on the ends. Okay, because hydrogen can only have 2 electrons, so it can ever only be on the ends. They're terminal. So let's see what's going to happen here. I'm not sure it's going to work out. Could work out, could not work out. That's 2 for hydrogen, 2 for hydrogen. This oxygen has 2, 4. Well, I'm going to need 6. I don't know if this is going to work. 8. Then the sulfur's got 8. This thing right here, make it, give it an octet, give that an octet. I'm not feeling good about this structure. Give that an octet, and then count electrons. That looks like a whole bunch of electrons, and I only needed 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Oh my gosh. Okay, well, it just doesn't look beautiful, but maybe it's 32 electrons. I don't know what to say about it. All right, so sulfuric acid, is it ionic? No, because it's a covalent compound. So it's either polar covalent or non-polar covalent. This is tricky because sulfuric acid is a strong acid, and it will dissolve in water, and it will dissolve 100% in water. And since it's a strong acid, it makes a super strong electrolyte. So while it doesn't look like a polar covalent compound, this thing will break up and make a super, super strong electrolyte. So will it be soluble in water? Heck to the yeah, it will. All right, so I think page 3, probably about the same. Same story, different verse. Do these or not do these? I don't want to overload you on work today, so I guess that's going to be it for this one. Good luck.